Hey there, Algebra 2 students. Today I want to talk to you about graphing other trigonometric functions like tangent, cotangent, and we'll see if we can get to secant and cosecant in this video or if we need a separate video for that. But today I want to start with the tangent video, tangent graph, sorry, tangent of x. You may not have heard this yet, but tangent of x is equal to sine of x over cosine of x. And so when we're graphing it, we want to consider the graphs of sine of x and cosine of x, right? So when the sine function is 0, the tangent function will be 0. So you may notice this is my sine function up here, and it crosses the x-axis at negative pi. And so at negative pi, we have a 0. It crosses the x-axis at 0, so we'll have a 0. And it crosses the x-axis at pi and up at 2 pi. And so we have zeros in both of those places. Now, when the cosine function is 0, that's bad, right? We can't divide by 0. We have a problem there. And so whenever the cosine function is 0, the tangent function will have an asymptote. So if we're coming along here and we see, at negative pi over 2, there would be an asymptote. And so we'll draw our vertical asymptote there. Cosine hits the 0 or the x-axis at pi over 2, and so here is another vertical asymptote, and again at 3 pi over 2. And at this point you may be saying, it looks like there's a pattern where the tangent function has an asymptote at odd multiples of pi over 2, right? So plus or minus pi over 2, plus or minus 3 pi over 2, and so on. Now, let's consider what happens in between the two asymptotes, right? Let's look at this chunk right here. We have a number close to 1 being divided by a negative number that is close to 0. So a number that is 1 divided by a very, very small number, but it's a negative number, means it's going to be down here. And it's going to work its way up until it gets to 0. And then here we will have a negative number divided by a negative number. And a negative divided by a negative is positive. And it will go up like this. Okay. And we could consider, again, negative. We would have a negative 1 divided by a number that is positive but close to 0. And a negative number divided by a positive will be negative. So it comes down, it's down like that, and then it starts to come up, goes like that. And this is the tangent function. It is a periodic function, right? And so it continues in this manner. These are not holes in the graph. These are zeros that I marked previously so that I would plot those points. Okay, there's your tangent function. It's a little rough there at the end. Let's see. There's your tangent function. Now, the domain of the tangent function is all real numbers except odd multiples of pi over 2, right? We saw that. There's pi over 2, 3 pi over 2, etc. And so there are vertical asymptotes at those places. The range of this function is all real numbers. The period of this function is pi. It repeats every pi units. And the x-intercepts happen at 0 and plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, etc. Okay, that is the tangent function. Now, let's take a look at the cotangent function. The cotangent function is the reciprocal of the tangent function, or in other words, you could say it's cosine of x over sine of x. And so whenever the cosine function is 0, we will have zeros. So the cosine function is here, there's a 0 there. There's a 0 at negative pi over 2. There's a 0 at pi over 2. A 0 at 3 pi over 2. Now, when is the sine function 0? When the sine function is 0, that's where our asymptotes will be for the cotangent function. So I'm going to go ahead. There's one at negative pi. There's one at 0. There's one at pi, right? And at 2 pi, the sine function is 0 here. So there will be an asymptote because we cannot divide by 0. So the cotangent is undefined at those points, right? Now, much like the tangent function, we need to consider, what's going on in between the asymptotes. So what's happening between negative pi and negative pi over 2? We'll start there. We've got negative numbers in both instances. A negative divided by a negative would give you a positive number, right? And the cosine is -1. This value is close to 0, and so it would be close to infinity. But it's going to start there. And then it's going to get closer to 0, right? And then what's happening here between negative pi over 2 and 0, we have a positive number that's approaching 1 divided by a negative number. And so a positive divided by a negative is negative, and it's going to end up approaching negative infinity as we go down that way. Trying to adjust this a little bit so you can see more of the cotangent graph, but as I do that, you can no longer see the sine function. So maybe we'll go up a little bit. Okay. Again, now we would have a positive divided by a positive. And so a positive divided by a positive will still be positive. And so it will come down just like this and go through the 0 at pi over 2. And then it comes down and approaches negative infinity. Because then we have a negative number divided by a positive number. And you can tell this is a periodic function. And so it repeats just like that. Now, the domain of the cotangent function is all real numbers except multiples of pi. At these x values, the graph has vertical asymptotes. And again, the range is all real numbers. And the period of this function is pi. The x-intercepts for the cotangent happen at plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, etc. Okay, I think that is enough for this first video. So this is tangents and cotangents, where the graphs come from. I hope this helps you in your graphing. We'll see you next time.